So in this question, we're told that the curve C has parametric equations x is equal to 2 cos t and y is equal to root 3 cos 2t, where t is going to be in the range between 0 and pi. So in part A of this question, we're asked to find an expression for dy by dx in terms of t. So what we're going to have to do here is to differentiate with respect to t our x equation and differentiate with respect to t our y equation, and then we can see what we can do with these two equations to give us dy by dx. So let us first note down that x is equal to 2 cos t and that y is equal to root 3 cos 2t. So we can remember the formula for parametric differentiation, where we have that dy by dx is going to be equal to dy by dt, and we multiply this by dt by dx. So what we can now see is if we differentiate our equation for y with respect to t, we'll have dy by dt. And if we differentiate our equation for x, we'll have dx by dt. So then all we need to do is then substitute dy by dt in here. And then we can do 1 over dx by dt to give us dt by dx. So let's calculate these now. So dx by dt is going to be equal to negative 2 sine t, because when we differentiate cos t, it goes to negative sine t. And then our dy by dt is going to be equal to 2 multiplied by root 3 multiplied by negative sine 2t. So here we've used the chain rule to differentiate our 2t, hence why we multiply by 2. Then we have the constant root 3 out in front, and then our cos 2t will differentiate to negative sine 2t, which gives us that dy by dt is going to be equal to negative 2 root 3 sine 2t. So then we recall the double angle formula. So we'll have that sine 2t is going to be equal to 2 sine t cos t. So just bear with this for just now, as this will become clearer as to why we use this in a second. So what we'll now do is we'll take our new equation for dy by dt and for dx by dt and substitute them into this equation here. So we'll then have that dy by dx is going to be equal to negative 2 root 3 sine 2t, and then we'll multiply that by 1 over dx by dt, which is going to be the same as dividing all of this here by negative 2 sine t. So we notice here that the negative 2's will cancel out, and we can then replace sine 2t with 2 sine t cos t. So our equation will then be as follows. We'll have root 3 lots of 2 sine t cos t, and we'll divide this by sine t here. Our denominator doesn't change. And then multiplying out the brackets at the top, we'll have 2 root 3 sine t cos t, and we divide this still by sine of t. And then we now notice that we have a sine t and a sine t here, which will cancel out, which leaves us to conclude that dy by dx is going to be equal to 2 root 3 cos of t. So now moving on to part B of this question, we're given some further information. We're told that the point P lies on C where t is equal to 2 pi over 3, and then we're told that the line L is normal to C at P. And what we're asked to do is show that an equation for L is 2x minus 2 root 3y minus 1 is equal to 0. So effectively what we're being asked to do here is to work out the gradient of the normal and then use that along with the point P, which we can work out using this t value we're given here. And then we use our equation of the line to substitute these values in, and then we can come out with this equation for L. So to begin, we recall that the gradient, so dy by dx, will be given by our answer to part A, which was 2 root 3 cos of t. So now if we substitute in t being equal to 2 pi over 3, we'll have that 2 root 3 cos of 2 pi over 3. And putting this into our calculator, we get this is negative root 3. Now the gradient of the normal is going to be equal to negative 1 divided by negative root 3, which is equal to 1 over root 3. So therefore we have that the gradient of the normal will be 1 over root 3. And let's denote this by m, as this is normally used for gradient. So the next thing to do is we recall that t is given as 2 pi over 3. And we know from the question that x is equal to 2 cos of t, and y is equal to root 3 cos 2 of t. So what we can now do is we can take this value for t and substitute it into our two equations. And this will give us an x coordinate and a y coordinate. So therefore x is equal to 2 cos 2 pi over 3. And putting that into our calculators, we have that x is equal to negative 1. And likewise for y, we'll have root 3 cos 2 times 2 pi over 3, which again, putting it into our calculator, comes out as negative root 3 divided by 2. So we now have all the ingredients to be able to work out the equation for L. We have our gradient, 1 over root 3, and we have our x coordinate, negative 1, and our y coordinate, negative root 3 over 2. So we'll now use the equation of a line to proceed. So we have y take away negative root 3 divided by 2. And this is going to be equal to m, which is our gradient. So 1 over root 3 multiplied by x minus 1. So then this leaves us with y being equal to 1 over root 3x, and then we multiply 1 over root 3 by 1, so that will give us plus 1 over root 3, and then we subtract root 3 over 2, and then simplifying this, we have y is equal to 1 over root 3 multiplied by x, and then we subtract root 3 divided by 6. So now we'll take a quick look back up the question and see what we're aiming for. So we were aiming for 2x, negative 2 root 3 in front of the y, and then negative 1 as a constant. So we need to think, what can we do to get this into this form? So we need to first get rid of all the denominators here and see what this will do for us. So multiplying everything by root 3, we'll first get that root 3y is equal to x minus 1 over 2. We'll then multiply everything by 2. So just to remind this stage here, we're multiplying by root 3. And then this stage here, we're going to multiply it by 2. So that will then leave us with 2 root 3y is equal to 2x minus 1. So looking back to our question, this is starting to look very familiar. So we can just rearrange this ever so slightly, and we'll then have that 2x minus 2 root 3y minus 1 is equal to 0. And we've therefore completed the question and found the equation of the line L in the required form. Now taking a look at part C of this question, we're now told that the line L intersects the curve C again at the point Q. So we already know that the line L intersects the curve C at the point P from part B, but we're now told that the line intersects the curve again at the point Q. And what we're being asked to do is to find the exact coordinates of Q. So we're going to quickly recall that x is equal to 2 cos t and y is equal to root 3 cos 2t. And the plan of action here is going to be to substitute x and y into the equation of the line which we solved in part B. So we recall that the equation of line L, and that is going to be 2x minus 2 root 3 multiplied by y minus 1 is equal to 0. So what we'll now do is we'll substitute in x and y into this equation here. So that leaves us with 2 lots of 2 cos of t. And then we're going to subtract 2 root 3 multiplied by root 3 cos of 2t. And then we're going to keep our negative 1 on the end there. So now we'll tidy this up a little bit by expanding the brackets. So 2 multiplied by 2 cos t, that is going to equal to 4 cos t. And then negative 2 root 3 multiplied by root 3, that is going to give us 6. So we'll have negative 6 cos 2t. And then our negative 1 will remain on the end. And that's all still equal to 0. So just to remember, what we're doing now is we're just going to take this equation and solve for t. So recall that 6 cos 2t by the double angle formula is going to equal to 6 lots of 2 cos squared t minus 1, which is going to be equal to 12 cos squared t minus 6. So the reason we want this is then we'll have a quadratic, we'll have a squared term, we'll have a simple t term, and then we'll just have a coefficient there. So we'll now substitute this 12 cos squared t minus 6 back into this equation. So this is going to leave us with 4 cos of t minus 12 cos squared t, and then we have this whole term multiplied by negative, so that will then be plus 6 minus 1 is equal to 0. So we can see here that plus 6, negative 1 is going to be equal to 5, and then to make this slightly easier, what we're going to do is multiply everything by minus 1, so we'll just note that in here, times by minus 1, and that's going to then leave us with 12 cos squared t minus 4 cos of t, and then we have 6 minus 1, which is 5. We then multiply by minus 1, which gives us negative 5, and that's going to be equal to 0. So now we want to let theta equal to cos of t. And it doesn't matter, we could use theta, we could use any letter, but in this case we already have x's, we already have y's, we already have t's. So I think introducing a new variable theta is the best option. So we can then rewrite this equation here, and we'll write it as follows. We'll have 12 theta squared minus 4 theta minus 5, and that's going to be equal to 0. So now what we can do is we can solve for theta, and we'll do this using the quadratic formula. So that then means theta is going to be equal to 4 plus or minus 4 squared minus 4 lots of 12 multiplied by minus 5. Then we remember to square root this term here. Then we're going to divide all of that by 2 times a, and in our case a is 12, so that is going to be 2 times 24. So then putting this into our calculator, we'll have the positive square root will give us that theta is equal to 5 over 6. And then for the negative square root, we'll have that theta is equal to negative a half. So then recall that we let theta equal to cos t, so that then means that cos t is equal to 5 over 6. And then also cos t is equal to negative 1 over 2. So then quickly we notice that t is equal to cos negative 1 over 2. And putting this into our calculator, this comes out as 2 pi over 3. But we already know this, so this means that we can ignore this solution. So we'll just write here, ignore solution. So then from here, we can focus on this term here. Cos t is equal to 5 over 6. So let's now look and see what we can do to find the exact coordinates of Q. Remember, we've already ignored the cos of t is equal to negative a half because this already corresponds to the p coordinate from the previous part of the question. Now we want to find out the coordinate x and the coordinate y. But we already have that x is equal to 2 cos of t and that y is equal to root 3 cos of 2t. So this means that we can substitute in cos t equals 5 over 6 into this equation here. So we'll have that the x coordinate of Q is going to be equal to 2 multiplied by 5 over 6, which is going to be equal to 10 over 6, which is equal to 5 over 3. We'll have y is going to be equal to root 3 multiplied by cos. And then how do we deal with this 2t? So we know that t is going to be equal to cos negative 1 5 over 6. So this means that 2t is going to be equal to 2 times this. So therefore, what we can do is we can replace 2t with cos negative 1 5 over 6 times 2. And then putting this into a calculator, this comes out as 7 root 3 divided by 18. So therefore, we now have the x coordinates and the y coordinates of our point Q, and we can conclude that Q has the following coordinates: 5 over 3 for the x coordinate and 7 over 18 root 3 for the y coordinate, and therefore we've completed the question. So in part A of this question, there was 2 marks available, and we received our first mark for getting to this stage here, where dy by dx is equal to negative 2 root 3 sine 2t divided by negative 2 sine t. And then we received our second mark for managing to simplify this down using the double angle formula and concluding that dy by dx is equal to 2 root 3 cos of t. So for part B of this question, we receive our first mark for substituting t is equal to 2 pi over 3 into our equation of the gradient from part 1 to get negative root 3. We then receive our second mark for working out the gradient of the normal and knowing that it is going to be negative 1 over the gradient from the previous part here. So that's our second mark for getting 1 over root 3. We then receive our third mark for working out the coordinates of P. So that was x equals negative 1 and y is equal to negative root 3 over 2. And we do that by substituting 2 pi over 3 into our equations for x and y. We then receive our fourth mark for having the correct form of the normal equation, and this is here, where we have y is equal to 1 over root 3x plus 1 over 3 minus root 3 over 2. And then we receive our fifth mark for working algebraically on this equation here and getting to the required solution of 2x minus 2 root 3y minus 1 is equal to 0. Now for part C of this question, there was 6 marks available. We received our first mark for substituting x equal 2 cos t and y is equal to root 3 cos 2t into our equation of the line from part B of the question. We then received our second mark for using this double angle formula here. We then received our third mark for getting this quadratic here. So 12 cos t squared minus 4 cos t minus 5. We received our third mark for that. We then received our fourth mark for solving this equation. So we've done it using the quadratic formula, and then concluding that cos t was equal to 5 over 6, and then getting to the fact that cos t was equal to negative a half, and then discarding it due to the fact it was already used from the previous part of the question. That is the point P, so we hence ignore it, and that is how we get our fourth mark. We then get our fifth mark for substituting cos t is equal to 5 over 6 into our equation for x, and then doing the same for y, and we then receive the sixth and final mark for concluding the coordinates of Q, and that they are 5 over 3 and 7 over 18 root 3.